All right, so we are looking at units and measurements. Inside there, we'll find things like fundamental quantities, what will be, we define magnitude, derived quantities, we explain all those. This is just part one. So we'll look at also other units, okay? I mean SI units. So that is it. We need just to understand these things so that we don't get lost, all right? We need to understand so that we don't get lost. We need to know as we are dealing with those advanced ones, we need to understand that what you are trying to find is magnitude, and magnitude looks like this. All right. So without wasting our time, we can start. All right. So it will be very important to understand the basics, then, because it is from these basics that will build up. All right. So um when you talk about measurements, okay, as we know, physics is based on measurements of the physical quantities. What are these physical quantities? Things that we can measure. All right, we use to describe the changes that take place in our universe, because these physical quantities, for example, I'm saying no, the height has changed, you see. So that's a physical something that we can measure is called a physical quantity, and it changes. So we need to have interest in studying something that changes, because it is not the way we found it at first. So physics hence come with an important law of knowing, and also updating us on what changes around our universe. So in order to measure physical quantity, its value is compared with that of the standard or same kind. All right. So we'll be able to measure because, for example, we are saying, no, we have the height of a table has 2 meters. All right. Then as things changes, we'll find that we'll say, let's say the table has just increased due to expansion and stuff like that, and we discovered, say, it's now 2.5 meters. So this means that there was change in height, and we need to understand this because it will affect our actually coming generation. So we'll be there measuring, all right. Hence physics play an important role in actually discovering changes in our physical quantities, things that are around our universe, called physical quantities, those things that can be measured, e.g. temperature. So we need to understand that temperature, it is actually measured using Kelvin. So our children, our generation will be able to measure the changes and also discover the change in temperature, what causes the temperature change. So all those things. So hence physics plays an important role in our environment. So um this standard is called, so the standard now of the same kind is called unit of physical quantity. All right. So we'll be standardizing based on the units. All right. For example, temperature will standardize with the kelvins. All right. Then a physical quantity, we need to know that is anything that can be measured and expressed in the form of rho. Sometimes by this I mean in the form of a formula. That's a law. So a physical quantity, in short, is something that can be measured. For example, temperature, height, area, density. Okay, anything that can be measured is called physical quantity. All right. So let us see now some uh, fundamental quantities, stuff like that. So the other thing that we need to understand is a fundamental quantity. All right. So fundamental quantities, these are quantities. All right. These are quantities that can be measured as well, but they're just fundamental. They are not derived. They are the basics quantities. All right. For example, I talk of temperature. All right. It is just the temperature. It is not coming from any formula. You get me? So that's what we mean when you say fundamental quantities. So I'll show you the list of fundamental quantities. There are 7, those that were selected worldwide list to say these are fundamental. And let me just show you. So these are the one we have the length, All right, mass, time, temperature, current, amount of a substance, luminosity of intensity. These are what we call fundamental. They are just important and basic before we get into other things. All right, okay. So these are what we call fundamental quantity. Okay, so having an understanding on fundamental quantities, we can now say what is the magnitude. Magnitude will be an extent of or something, the value given, but mostly the magnitude will be broken down into, for example, it will be represented by this. All right, so I can say this is magnitude of A, which is equal to root of the sum of those products. So for example, I have y squared plus x squared. So what I'm going to find is called a magnitude, and magnitude is expressed in the form of these represent magnitudes. So let's say magnitude of x will be like that, is equals to, let's say, 20. All right, so it's just a value without units. Okay, understand this. Then there are what we call derived quantities. Derived quantities are quantities that are gotten from these fundamental quantities, which are basic quantities. For example, I'm talking about um density. All right, so density, for example, I'm talking about density. Density will be found by saying is given by mass over what? Volume. So this means that is gotten from the combination of two. You can even check from its units, right? You find that density, because it can be mass, I mean grams per centimeter cubed, right? So this means that this combination will tell you. But for the case of temperature, where I said these are fundamental, all right, temperature, you find that temperature is given as just Kelvin. All right, even the mass, you just find it kg or grams. So those are what you call fundamental. Now coming to derived, they are gotten from these fundamental. All right, then that is it about derived quantities. You'll be able to tell that, okay, this one is coming, like for example, what of force? Force is mass times acceleration, right? You find even the units that they actually comes like that. So that's what we call a derived. They are derived from from these fundamental or basic units. All right, so that is it about derived units. Then we can also talk about the international system of units. So this is the worldly, okay, worldly wide, like accepted the standard of units. So the world had to come up with, so okay, how are we going to be, in as much as we do um trade, okay, we are trading international, but we need to have also the standard of naming our things. For example, in UK, you say, okay, this is the density is expressed in meters per second. So we are saying, let's say, the height of a piece you are buying from UK, it has length, um, let's say 5 centimeter, or let's say 10 centimeter or 15 centimeter length. All right. So even in Zambia, you need to understand what 15 centimeter is. All right. So hence they came up with the international system of units, which are SI units. All right, so let me show you some accepted and worldly, I mean accepted international, I mean way of unit, I mean giving units these. So these are the one. So first of all, length should be expressed in meters, and the symbol should be m. Time should be expressed in seconds. Always, please, these are the standard units. Then denoted by the symbol S. Mass, the standard is kilogram, not grams. Grams is just a case of where we have a small thing. So always kilogram for temperature. Then for I mean for mass, that is kilogram. For temperature now, um, temperature is always expressed in Kelvin. You have been seeing temperature in Celsius, Fahrenheit, but these are the best. All right, these are the best. Then um electric current, which is amps, right, it will be expressed in ampere denoted by A. So these are the one accepted worldly. Okay, then The amount of a substance which is a mole will be expressed at this as the units. So these are the units that will be putting luminous intensity, which will be, actually the units are called candelas, but we use a CDRs to represent that candela. We can't write the whole word in our units. So actually, this is what the world, those especially from France, that's where those are the one who had more knowledge about this physics, mass, measurements, instruments. Even the Bible was first translated in France. Okay, so France was, we had industrial revolution in France, so most of technology started from there. So that is it. Um, that's marked the end of part one, introduction to terms. Now we are okay. Part two, we advance to prefixes and other things, dimensional, and a lot more to say. So thank you very much.